I meant more like the graphing idea. Okay, well, we'll jump in with these then. I sent you home with a couple problems to do. Why don't y'all take a couple minutes, compare notes, talk to each other about these, and then we'll talk about them together.
Take out the x and just just 3x's here. Technically, you could still factor that, but it's going to be positive. I factored it twice. So it takes the x one time and just time instead of factoring and split it up. Right out to 6 x plus 3 from there. Yes, it was 6. Pretty much the same thing with the first one. Minus 10x to the bring us to 7. This is the whole part is weird.
Did anybody come in after I see that next week's notes? Okay, so let's talk about D. Where should we start? Yeah. Again, since we're leaning on factoring harder, right, for the higher degree stuff, I don't have, I lose the kind of general formula stuff. We don't have as many options. Kind of have to lean on the factoring idea more. Factoring only works if we've got everything on one side of the equation. So first thing would be to rearrange. I'm going to put the minus 10x squared in the middle just because we're, kind of used to seeing things in descending order like that. Again, that's to get everything equal to 0 so that if I can figure out a way to factor, we can factor and actually use that to get somewhere. Now we got to look at this and, this is the uncomfortable part when we have to think, right? And notice stuff. So 3x cubed minus 10x squared plus 3x equals 0. Again, this is good. Left-hand side, what do you notice? They all have an x. Since they all have an x, we can factor out an x. And when we factor out an x, what's left? 3x squared minus 10x plus 3. And since this is a product equal to 0, zero product property says that either this one's 0, there's one of our solutions, right? One of an expected 3, because it's cubic, right? We might end up with, a repeated root, but, we kind of go in thinking there will probably be 3. There's one of them. The others are going to come from figuring out where 3x squared minus 10x plus 3 is 0. What kind of thing is that? And what do we know about quadratics? Everybody all together with feeling. All right, thank you. Okay, so solve that quadratic, right? How do you want to do it? Say it again.
Negative.
Oh, factoring it? Okay, yeah. Okay, so yeah, that does factor. We'd be looking for things that multiply to 3 times 3, so 9. and add to -10. -1 and -9 should do the trick. And let me put an asterisk here or something. We're solving a quadratic now, right? Solve the quadratic however you want to solve the quadratic. At this point, that should be a thing that, like, we can just kind of jump right into. If you want to use the quadratic formula, use the quadratic formula, right? If you want to factor it, factor it. I'm going to factor it just so that we've, looked at the factoring thing again, because maybe we haven't done that, right? If you don't want to do this and you want to choose quadratic formula, go for it. You're going to end up in the same place. So a times c is 9, b is -10. To factor a trinomial with a leading coefficient that's not 1, I look for a pair of numbers that multiply to a times c and add to b. That would be these. You can use those to split the middle term up, and then you can factor by grouping. So 3x times x minus 3 minus 1 times x minus 3. So this factors as x minus 3 times 3x minus 1. And then another application of the zero product property on that factored thing, we get that x is 3, or 3x minus 1 is 0, so x is 1/3. Again, if you don't want to factor it like that, if that part was, scary for you, then just ignore it and use the quadratic formula. You know how to use the quadratic formula, I assume, at this point. Yes, Pat. So factors of 9, 1 and 9, or 3 and 3. Since this is positive, they have to have the same sign. And then I want a pair of those that add to -10. So -1 and -9, those add to -10 and then multiply to 9. Okay. So when you do the FOIL expansion kind of thing, the outer and inner and first and last and all that stuff, the way that works out is that if we're going to factor a thing like this, we need to look for, a times c. That's the difference. So that's how it factors. Again, if you want to factor it, if you don't, that's okay. Don't worry about it. Just use quadratic formula. You get to the same place. Often, that's probably what I would do too when I see a leading coefficient that's not 1. Just, I might think about it for a few seconds and then say, well, to heck with it. I'm just going to use the quadratic formula and go for it. Yeah. Uh-huh. Okay, so, or quadratic formula here, right? There's our 3 solutions. Okay, and again, because of the common factor to begin with, right? Okay, everybody all right with that? I'm gonna make some room here. Okay. And again, reminder, there's a prettier version of all this stuff in Blackboard. All right, what about F? Cubic. Pretty much any kind of polynomial stuff, though, and really a lot of solving stuff in general, we want everything onto one side of the equation. So I'm going to move these over. To get x cubed plus 3x squared minus 19x minus 57 equals 0. As usual, I'm happy about. Because now if we can factor it, I don't need this. Now if we can factor it, we can solve. So can we factor that? Okay, by grouping. Nothing common to all 4 terms, but if I pair them up, I can find some common factors there. So what do x cubed and 3x squared have in common? You can take x squared out. If you take x squared out, what's left? Okay. What do 19x and 57 have in common? 19, yeah, this is maybe a little less obvious, but 19 is prime. So if I'm gonna check this, really what I need to do is divide 57 by 19 and see if it goes in, right? And it does, 3 times. Since these are both negative, if I take negative 19 out, then what's left behind? X plus 3. And that's kind of what the whole thing hinges on, right? Having these identical so that it's a common factor, so that then I can, factor again and take that out of there. So x plus 3, and what's left would be x squared minus 19. And then, ta-da, it's factored. Yesterday, we also talked about that as, I could, if this is throwing you off somehow, you can also probably treat these 4 terms as though they're the results of doing an expansion, right? Like a FOIL type multiplication, and kind of like educated guess your way through what the pieces need to be like, right? X cubed, okay, well, x squared and x is how I can decompose that. Okay, then the next term, 3x squared. So opposite where I put the x squared, I need a plus 3. Negative 19, okay, opposite where I put the x and negative 19. And then, check, like multiply it back out and verify that it works, and that's it, right? There's not, like, factoring is not some magic, like, mystical thing, right? It's just, here's some stuff that can make it work. So if some other method works for you, then go for it. We've got it factored, though. That was the important part. Because now the zero product property says that either the first factor is 0 or the second one is. Now this would say that x squared is 19. Wait, first of all, what kind of thing is this? Quadratic, and
Everything.
right, okay, so we can solve this somehow. I'm gonna solve it one way, you can solve it a different way if you want, right? What's A? What's B? Try again. What's B? AX squared plus BX, right? B is 0. B doesn't show up. What's C? Negative 19. Okay, if you want to use quadratic formula, go for it. A is 1, B is 0, C is negative 19. It's going to turn out to be pretty easy then because all the B stuff is not going to show up, right? I'm going to move 19 over and then take a square root. Square root of 19 is, well, the square root of 19. Sorry, I didn't mean to write a squared again. Plus or minus the square root of 19. So our solutions are -3 and the square root of 19 and negative square root of 19. Okay. But again, like this part, you have some options. If you want to do it a different way, that's fine. Yeah, right. Yeah. Yeah. Plus or minus always means 2 things, right? We're just lazy and don't want to list them. So we write it as plus or minus, especially with like the formula, right? I don't want to write the whole quadratic formula down twice, once with a plus and once with a minus. So we write it as plus or minus. But yeah, it always means 2 things.
It's the answer is square.
Well, yeah. So where we went from here was to take the square root of the left-hand side, right? But when you take the square root of the left-hand side and the square root of the right-hand side, as part of that, you pick up a plus or minus. Really what's happening is that this isn't just x, it's the absolute value of x, and that's how you get the plus or minus. But yeah, that comes along with it. Okay, everybody good so far? Yeah, all right. Well, what if none of that stuff works? This is degree 4. Is there anything common all the way across? No, okay. And there is a, degree 4 formula thing, but it was, you know, very scary, right? Like, we'll just remember that, you know, it's not a thing that is reasonable to use. Well, what else could we try then? Quadratic formula? Okay. How? Tell me more about that. Okay, so let's think about that a little bit. Quadratic formula is for quadratics. Is this quadratic? Because it's got a fourth power, right? Okay, but I mean, if I don't look at it too close, right? Like, everybody squint your eyes at it really hard. It kind of looks like a quadratic, right? Like, it's got the same number of things. It's got 3 terms. If I look at kind of the sort of pattern, right? The power on this thing is double the power on that thing, and then there's this constant piece. So I mean, it's not totally unquadratic like, right? It sort of has the shape or the form of a quadratic, only what's different? The powers are 4 and 2 instead of 2 and 1, right? Okay, well, let's think about this thing for a second. We'll put a pin in that and come back to it. What can I do with this? Quadratic formula, or we could factor it, right? Just for the sake of, you know, the time thing, let's look at how this would factor. Factors of 5 that add to -6. -1 and -5, right? So that when we multiply it back out, we get that times that, which is x squared, and that times that, which is -1x, and this times that, which is -5x, and this times that, which is +5, and then we combine like terms, and we end up back there, right? Okay, well, what would happen if I changed these x terms to x squared? How would that change things when I expand it back out? X squared times x squared, which is x to the 4th, -1 times x squared, which is -1x squared, -5 times x squared, so this would be squared. If I combine like terms, what do we get? Oops. Oh, hey, that's it's the thing, right? Okay, so the sort of shape, the form, the pattern, however you want to say that, of this thing, because it looks like a quadratic, right? It's got kind of the same shape as a quadratic. And because I know that if these were 2 and 1, I could factor it as x minus 1 and x minus 5. And the only difference is that, well, those powers are double what I'm used to, right? But we just said, hey, well, let's try it, you know, see what this does. And again, if I expand this back out, I get x to the 4th minus 5x squared minus 1x squared plus 5, which is the thing that we wanted in the first place. Fireworks and rockets and, you know, gold stars and like everybody's. I can factor this thing as a trinomial because it's got 3 terms using the same kind of factoring stuff that we're used to. The only difference is that if I want the powers to match, to get x to the 4th and 6x squared, I need to make these, you know, double what we're kind of used to, right? What if those powers have been 6 and 3? Do the same thing, but make these x cubed, and it's still going to expand the same way and, you know, end up at kind of the same place. Okay, does that mean that we have to factor it? Well, actually, first let's finish solving the thing real quick. The point of getting it factored is, as usual, so that we can use the zero product property to split them up. This is quadratic. so we know how to solve it. This is quadratic, so we know how to solve it, right? How do you want to solve those? Yeah, I would go with the easy way too, and just add one over and then take a square root. So x is plus or minus 1. And here, plus or minus the square root of 5. Does that mean we necessarily had to factor it though? We could, right? Factoring works, right? We factored the thing, we multiplied this back out, we showed that it's the same as the expression that we started with. So the factoring does work. These are the solutions, like we haven't done anything, illegal here. We didn't necessarily have to factor it though. Once I recognized that quadratic, sort of form or shape, so this looks like a quadratic, kind of, right? Except that the powers are wrong or double what they ought to be. Could we use the quadratic formula then? Quadratic formula, normally we're taking something like that and finding x equals, the whole thing, right? How is this different than this? The powers are, double, right? Okay, well, I could think about that if we wanted to, like x squared squared. We just like throw some parentheses on to kind of group things up. Those are the same, so let's just, not look at it for a second. I've got a thing squared minus 6 times that thing plus 5. Well, like we just saw, I can factor that then. Like this. And this could be anything in the whole wide universe. And it would still, when I expand this, fit this same sort of pattern or mold, right? Okay, well, if I ignore what that orange thing is, this is quadratic. It's quadratic in terms of whatever that orange thing is, right? So the quadratic formula applies. And you can take negative b and b squared or a c2a, and we can work through that. But rather than solving for x, we'd be finding whatever that thing is, right? So I could work through all this. And let's see. 36 minus 20, which is 16, which is 4. So 6 plus 4 over 2. 6 minus 4 over 2. So 5 and negative 1. So whatever that orange squiggly thing is, it's 5 or it's negative 1. Oh, sorry, positive 1. Positive 1. Sorry. 6 minus 4. 2. It's 5 or it's 1. But the orange squiggly thing all along was actually x squared. So x squared is 5, which means that x itself is plus or minus root 5. Or x squared is 1, which means that x is plus or minus 1. So I don't necessarily have to do the trinomial factoring thing. I do kind of need to recognize the, the quadratic like form of the thing, right? And that's usually what this is called in books and stuff, is treating things that are quadratic in form. Some books, some people would, do this a little more formally and say something like, okay, take this thing and introduce a new variable, let u be x squared, and then rewrite it. So this is u squared minus 6u plus 5, and then solve for u. And then figure out what x is based on that. That's really not any different than what I've done by squiggling over the x squared and treating it like it's got that same kind of shape. If this tracks better for you, then go for it. Probably if you look at the like help stuff in the homework, it's going to do something more like that, where you sort of assign a new like dummy variable to stand in, so that we can sort of look at the quadratic kind of shape or form of the thing. But really, it means the same thing as what we're doing here, saying, okay, well, the powers are double what they ought to be. Let's ignore that for the moment. Deal with the quadratic part of it. And then, kind of at the last moment, like as late as I can, I'll deal with the fact that it's actually x squared. Okay? Okay. So how do we recognize that, apart from the fact that we just talked about it, and this is the problem right next to it? It looks a whole lot like a quadratic, right? It's got that sort of ax squared, bx, c kind of shape to it, only we're dealing with a fourth power in a square instead of a 2 and a 1. Okay, so how would you like to go about this one? Do it. Okay, right, yeah, so 4, 29, 25. That one's squared. For negative 29 and 25, this is probably, it does factor, but I would probably go quadratic formula with this one if it's me. But again, we're solving it like a quadratic. You do it however you want. X squared would be negative b. B is negative, so the opposite of b would be positive. B squared 4 times a times c over 2 times a. Oh, well, yes, but we're going to square it anyway, right? Let me give me whatever the stuff under the radical is. How much? Nope. I don't know what it is, but it's not 441. Okay. And fingers crossed that 441 is a perfect square. Okay, good. Phew. So we get 29 plus 21, 50 over 8. And 29 minus 21, 8 over 8. So 25 over 4 and 1. But again, that was x squared. So if x squared is 25 over 4, then x is plus or minus the square root of 25 over 4, which is I hear y'all clicking buttons. I'm not asking a lot. Square root of 25 over 4. What's square root of 25? What's square root of 4? 5/2. Okay. It is. Yeah, it would be kind of a mess for them. Okay.
So would the answer be on the test +or -1, comma, +or -5/2?
Yeah, that would be fine. Or again, like homework is probably going to ask you to list them out as 4 things, right? Because, you know, computers are stupid about reading things, but, so yeah, it's those 4 values. I'm good with you leaving stuff as plus or minus, once it's simplified all the way down. Okay, anything else? Feel good about that? Or, you know, ish? Okay, ish is fine. That one's, you know, a little bit messy because the coefficients are big. Okay, well, let's talk about what this looks like for inequalities then. I think if I remember correctly, yeah, on 7A, I printed 80 copies of this and then realized that I left that as equals. So change that to greater than, because I wasn't gonna, you know, reprint them all. That always happens. I'll be like standing there and the last one will come out and I notice the typo then. So anyway, we want this to be an inequality. So make that greater than. Solving inequalities. We're not going to do anything different than any other time we solve inequalities. So, what do we need to know first? Go ahead. Yeah, because the first thing is going to be solving the equation, right? The thing that's actually printed on your paper, like that's what we need to solve first. Charlie says take an x out. What's that leave? Which is quadratic, which is good because we know how to solve those. I'll do this part. Y'all real quick do that part. Okay. What'd you get? You can. It is. Middle terms would be minus 6x plus 3x, so that's minus 3. And then the last would be minus 18. So that is how that factors, which means the zeros are 6 and negative 3, right? Okay. Okay, what'd you get? Okay, something went wrong somewhere, yes. So negative b squared, which is going to turn into 9, minus 4ac. So 3, 9 plus 72 over 2.
Oh, I got -9.
Okay.
9, yeah.
Okay. Yeah, that's fine. Arithmetic stuff happens. So 0 and 6 and negative 3. As usual, I'm going to deal with the inequality
by marking those three values, right? The three things that we found when we solved. Those partition the domain of the function into 1, 2, 3, 4 subintervals. And each of those we want to just, make a yes or no, true or false decision about the inequality. So take a couple minutes, think about, that, how you would decide about the inequality. Right. Okay. You should get 0.
Okay. But it's
Because
not.
that's where we found it. You want to test the stuff in between. So here it's 4. We're asking where is it greater than? Oh, wait.
Yeah, I, it was a negative and I'm trying to cover it.
Okay. So 14 is 14 greater than 0. Okay, so it does work on this end. And then, check the others in like the same way. So again, it's not that we want to test what happens at these points because we know what happens at those points because that's how we found them in the first place, right? We want to know what happens in between. So if you're going to pick test values, pick things that are in between and around those. The other way you could do this is to, test those points not like by plugging them in and, punching it onto a calculator. That's fine if you want to do that. Another way we could think about this, though, is graphically. What does the graph of this thing look like? The degree is 3, so the ends go in opposite directions and it winds up pointing up. It's degree 3. We just found 1, 2, 3 zeros. So they've all got multiplicity 1. They all just go straight across. So the graph of this thing looks something like that, right? Does that tell me all the information I need to be able to answer the inequality? Yeah. All I need to know is where is it greater than 0? Can I tell from looking at that graph where it sits above the x-axis? Yeah. So again, if you want to, plug in points, that's fine. Or if you want to, use what we know about sketching the graph, say, okay, this thing looks like that. So if you're out here, is the function greater than 0? Is it sitting above the x-axis? No. In here, is it sitting above the x-axis? Yeah. Here? No. Here? Yes. Right? We know enough about sketching the graph of a polynomial that like I can, just kind of drop that thing on there and know that that's what it looks like, again, from the end behavior and from looking at the degree and what happened here. So if you're happy with that, that's fine. If you're more happy with, plugging in -4 and -1 and 2 and 8 or something, then by all means, go ahead and do that. That's fine too. What's the solution set then? -3 to 0. Those should be, yep. It was strictly greater than, so those should be open, so parentheses, and 6 to infinity. Yep, good. So the only difference in, this and the quadratics that we did a few days ago, so I've got one extra 0, which means I've got one extra, interval I need to consider and test and decide about. Okay. It does mean that if the way you had been, approaching the quadratics was to find the 2 zeros and then just sort of guess about whether it was the stuff outside or the stuff in between, you've lost that, right? Like that's not going to work anymore because there are more pieces, there's more stuff going on. Okay.
So this is saying that anything between -3 and 0 should be included. This means anything between -3 and 0. And then anything beyond 6, this is anything beyond 6. Yeah.
Okay? How we feel about that? Well, if this had been greater than or equal to, then all those will be brackets, except for the last one. Yeah. Okay. But big picture terms, same idea, solve the equation, then decide about the inequality and write it down. Y'all do B. I'll leave this here. X squared minus 1 is 0. If you have or X squared is, which means X would have to be okay. So
Plus or minus 1, or is zero.
In the
answers.
right. Yep.
That's it.
Positive, negative, each. So either that's 0 within the because negative 1 squared is 1 plus 1 here. Okay. Or what else? Right, that's not in it. So not 0. Right. Okay, so not that. This is what the so
Now we're talking about your one.
so
Because we graph it, you
try
know,
this over.
and then you know, if negative 1 and 0, it comes back up. It is also comes back down. So the value between negative 1 and yes, yeah, 1 before. So
Negative 1. Okay, so 0 and 1 to negative. Okay. Any of those things make something here.
Try plugging in. Yeah.
Okay.
Okay, so what are solutions to that? 0, 1, and -1, right? There's a common factor of x squared. If you take it out, it leaves that. So x squared is 0, or x squared minus 1 is 0. Okay? So we need to know what happens on either side of -1 and 0 and 1. So we're, again, testing values somehow where I've made these like orange marks, right? Something in between and around each of the zeros that we just found. You can do that numerically if you want. You can do that graphically if you want. If we think of this as a function, what do the ends look like? That. We found how many zeros? 3, but one of them's got multiplicity 2, right? So what happens at 0? Bounces off, and the other 2 it goes across. So we've got this big sort of W-shaped graph. That needs to look something like that. And again, like, you have a graphing calculator too, so like let that help you with that part if you want to, right? If you need to. So this thing looks like that, and we're asking for what? Where it's less than 0. So is this less than 0? No, because it's sitting above the axis. How about here? Yes. And the next one? And the next one. Okay. What's the solution set then? Brackets, -1 to 1. I don't need to worry about, separating 0 out, because if I just started listing them, I would get that, but those both say that 0 is included, right? We use the union to join together things that are disjoint, that have a gap between them. These don't have a gap between them. So we can mush them together. Okay? All right. Y'all have a good weekend. I'll see you on Monday. If I can help with anything between now and then, just let me know, please.